Thanks for joining us today, everybody. There's a number of things I want to show you with regards to CATIA and SpaceClaim and the interaction we have between the two. First off, I want to highlight all the different file types that SpaceClaim can open. Now you'll notice a lot of different native file types from other CAD systems, and there's CATIA and V4 and V5 right there. Yeah, we can absolutely open up V4 files and go back and forth between V5 and SpaceClaim. I'm also going to show a JT file a little bit later on too. But the important thing to note here is that SpaceClaim can open up all these file types and then generally save out to any neutral file format, so it's extremely interoperable. And another thing to note, something that I'll show just a little later on, when I go to look at the CATIA file import options, there's importing part manufacturing information, or PMI. So yeah, we can absolutely import that, and I'll show that in just a little while. Final thing I'll note about import-export options is that this can really save a customer or someone time and a lot of money when they don't have to carry multiple versions of CATIA, because we can export out to any of these versions you see here. So you have SpaceClaim, you can export out to any of those. You really don't have to carry the overhead of multiple versions of CATIA in your company. So that's all I want to show you in the way of options for importing and exporting files. Let's go right into the demonstration. Let me show you a number of things. First off, what I'm opening right now is just a simple part given to us by an automotive manufacturer, and it's actually a V4 file, so these are a little bit older, but absolutely SpaceClaim can not only open these files but edit them in the unique direct modeling fashion that we do. Most of my editing is done with this tool called Pull that I have highlighted right now, and I'm just grabbing a hole, grabbing the diameter, pulling on it, making it bigger or smaller. Extremely easy to edit geometry in SpaceClaim. Now let's say that I want to edit the four holes in total all around there. Well, it's not difficult to control select all these holes, select them, and start pulling on them all at once. But say I have 100 of those holes in the model. Well, SpaceClaim gives me something unique called Power Select. It's a great way to quickly grab similar geometry in the model. So in this case I've selected all 4 of those holes with a click of a button, so whether it's 4 or 100 it doesn't matter, and I can easily go modify those on the fly just by pulling on them. So quick model regeneration, dynamic changes right there. So just moving around the model to show you some changes that I could make. There's a small little boss, some sort of maybe a support rib right here. Let's say that you don't want that anymore. Getting rid of geometry is so simple in SpaceClaim. There's a lot of ways to do it, one of which is to just pull on this face until it's now infinitely small or gone. And just like that, that small little rib is gone. Now, speaking of ribs, let me show you some of the other things that I can do in SpaceClaim. I showed you that pull tool. Let me show you the move tool now. I could grab a rib and just move it any which direction, any specific distance that I want. That's right, I can work with specific distances and measurements. Up until now you've seen me just do free-form changes, but I could always put precision into the model at any time. And just by holding down a control key, just a simple Windows shortcut, I could make a copy of this rib, and let's say I want to make that exactly 60 millimeters away. And I could make another copy and go right in the middle somewhere. We'll call it 30 millimeters. So it's extremely easy to make changes and copy things in SpaceClaim too. Now let me make another change. I'm going to take one of the faces of that longer rib and just copy it in. Now this rib's got 2 different faces on it, so copying that is not quite as straightforward. But I've just copied one face, and all I have to do to recreate it is just drag on it. And I know that ahead of time that rib was about 1.58 millimeters thick. So now I need to clean up the ends and actually extend that a little further, and that's all done again with the Pull tool. So far I'm just using tools like Pull and Move to modify this geometry any which way I need to. And now that's its own rib, and I can do anything that I want to with it. I can modify it just as I did with the other ones. But you notice those horizontal ribs I created 2 of them. They're now broken up into sections, so I could treat those independently and stagger them if I wanted to. So any kind of changes I want to make. If I need to just tinker around with the model, add some supports, do whatever, I'm free to do it in SpaceClaim. And a change that I think is a little more slick, for lack of a better word, and impressive, I could actually rotate one of these ribs too. So powerful modifications to make any time I want. So moving around, a couple other things I could do. This model has generally just a thin body, a wall thickness all around it. Say I wanted to increase that a little bit. I could just double click to get all those faces around the perimeter and slowly increase that thickness if I wanted to. We'll go up something like 1 millimeter. And now that's 1 millimeter thicker all around. Alright, the last change I want to show you, the last kind of change that I want to bring to your attention is a little bit more of a dramatic change. Now I've gone into a cross-section mode, which means I'm slicing the model somewhere at an arbitrary location, and I can always modify the geometry in a cross-section mode. That's impressive in and of itself, but making the kind of changes I'm going to show you now are even more impressive. I could take something that exists as a small arc, or down here actually a thin body that's two planes, and actually turn that into a bent section. Before I do that though, I want to add some kind of associativity. Now keep in mind, this is imported geometry. I didn't create this from the ground up and build my design intent in it in its entirety. I'm just putting design intent in right now. And so all I've said with these two walls is that they have an offset relationship, meaning the thickness needs to be maintained. And so I have a unique tool here called bend. And if I go grab that line, which is really a plane, and turn it into an arc, I preserve the wall thickness. And I get a concentric relationship between those two arcs. So that's an impressive move that I could just do on the fly in SpaceClaim. So that's all I want to show you on this particular model, going from importing a V4 model. And now I could save this out not just as a SpaceClaim document, but let me show you all the file types. Here they are. You'd probably want to be saving this out as a CATIA part file. And then there's all those neutral file formats in the list as well. Alright, so let's transition over to another model. This is actually a JT file given to us. JT files are a very popular lightweight file format. And this was given to us by an automotive supplier. And I'm just going to change the colors on this for a minute, make it a little bit easier to see, and maybe call it orange. So given to us by an automotive supplier. And again, whether you have a JT file, whether you have a step file, an IGES, a SpaceClaim document, CATIA, it doesn't matter. You're free to work on that geometry in all those intuitive ways that I've shown you and that I am showing you now. So I'm taking some holes, making copies, moving them around. I could take a small cutout over here, say I need that to be shifted over ever so slightly, or maybe an inch or so. I can do that. It's easy to do. Alright, now at this point I've imported the model, I've made a couple changes, but maybe you're a designer or an engineer and you need to convey all the changes you want to make to someone else. So you want to compare the original and the final model. Well, first off, I'm going to use a common Windows tool to modify or to undo the operations I just did and save this imported JT as a SpaceClaim document. So let's go find that directory where all this is saved in. And we'll save this as the same name, but now it's a SpaceClaim document. And then using the redo button, I can get right back to that final point that I was, and I think it was right there. Alright, so let's keep moving. I changed the location of those holes. I added a couple and moved the location, changed the location of that slot. But up until now, I've just been making modifications to the geometry that's existing. Simple changes, nothing earth-shattering, but still very powerful. But what if you want to really add some more material and do what we call slice and dice the model up and really make some serious modifications to that? You can do that with SpaceClaim. What I'm doing is I inserted a plane, an arbitrary plane, into the model, and I'll use that to cut up the body. Now that it's cut up, I could take that section and move it as far away as I want. We'll say 30 millimeters, and let's go in the green direction as well. So I'm pretty much moving it around in that red-green plane. So maybe that's where I want that small boss and that the support ribs to be, and I need a new section of material to join those two back together. Extremely simple to do. In SpaceClaim, you use the pull tool, primary geometry creation button. It's so easy to do. Doing a change like this in CATIA, if you're not a power user, will take you a long time to do. But we give you such simple tools to be able to make a change like that in seconds. Alright, so another change I want to show you. What if you have an existing model and you want to incorporate it into what you have here? Well, I'll take a SpaceClaim document I have called connection. So it's just a small little file. And I'll actually make it internal, so I'm making a copy of it in here. And one other thing I want to do, when I made that cut with that plane, I inadvertently sliced a little section over here away. And I can see that because I've got two solids. That's not a problem. I use the combine tool, which cuts things and merges things together. And I merge that body all back to one. So I'm good to go. So let's say that I want to incorporate this small little doghouse, I'll call it, and put it somewhere in my model. And I'll just do a free-form movement of where this needs to go, somewhere on that surface. Now, a couple problems. These aren't merged together. There's two separate solid bodies. And my orange body has a thickness of about 2.5 millimeters. I can grab a couple faces on the model and see down at the bottom that it's 2.5 millimeters. And so I really want to take the green model, not only incorporate it into the orange, but shell it out. So I've got a tool to do that. I click a button called shell, I grab a face, and I can put in the exact value I want. But now it's time to take care of all the interference I have. That's done with that combine tool. It's so simple to use just by grabbing the areas that I want to cut up, and before you know it, I've got two merged solids together. And I can easily add some rounds to this to make it a little more uniform and make it look like the rest of the model. And actually get the same size as the other rounds just by referencing them. I don't even have to know the values there. So that's an extremely fast way to modify this. I showed you that cross-section mode a minute ago. Let's go into that again because there's really some powerful things you can do here. I'm looking at the model in a cross-section mode, and it's a great way to give you an idea of what your model looks like on the inside and make modifications and see what the effects are going to be. So I'm editing a 2D cross-section, but I'm actually editing the 3D model as I do it. That's really powerful. And SpaceClaim lets you do this at not only just certain what I'll call milestone locations, but anywhere in the model, any arbitrary cross-section. So I'm going to say let's just turn this 90 degrees from wherever it happens to be and make some more modifications. Maybe I want to take that face, use my move tool, and rotate it a little bit. I preserve the wall thickness, easy to do. Maybe the bottom of this doghouse is a little bit too low. I want to have some clearance. So I just pull on some faces, and I'm done. And I could go around and add rounds on the inside if I want to. It's just all too easy to modify things in this tool. Alright, so let's say that is the bulk of the changes I want to make. That consists of all of them. Let's go ahead and save this document out as a new version. So it has the same name, but it's called .2, so it's related to the original. There's a couple different ways that we let you convey changes to people. We think the most effective way to do it is with this document or this method we have called 3D markup. And all I'm doing is inserting the two models right on top of each other. You see the transparent one, or the one that looks sort of transparent, is the original, and the opaque one is the new model that I just modified. And this is a 3D markup tool that we have. So what's the best way to convey changes that you've made in a model to someone? Well, we think dimensions clearly show that off. And so when you put dimensions in a model in 3D markup, we give you not only the location but is-was dimensions. So you see that distance is 57 3/4 millimeters, and it was about 27. And so dimensions that I put anywhere where there's a change, those are going to show up. So it's so easy to highlight all the changes on your model. Now sometimes dimensions don't always cut it, and you need some annotations, for example. So I could always say that I added a few holes and put a leader to maybe one of those, just to clearly point out the exact change that I've made to someone. But it's pretty obvious all the other changes I've made on this, right? Well, not really. There's still a couple more. It can be difficult to tell. And so we give you a tool that just makes it painfully obvious, all the changes you've made. Every modification shows up in color. You see all the green faces are new, and you can see on the doghouse over here. And yellow just means there's a location change. And there's an edge change on any blue faces. So someone could clearly go in and see everything that's been modified. Now the great thing about this is what you're looking at is a slide right now. And what do you do with slides? Well, I could create additional ones. And I could save these out as a PowerPoint document. And so what you're seeing on the screen is saved out as a JPEG picture and gets inserted right into PowerPoint. I could add as many slides as I want to, but I could also add iterations, as many as I want. I just have 2 right now. I could add 3, 4, 5, and keep going. And so this is really relevant and great. We're getting a lot of great feedback from people that use this for design reviews internally. They send it to their vendors, to their customers. Great collaboration tool for any and all industries that use CATIA and need to collaborate with anyone, really. Now let's move on to another example. This is a CATIA V5 part given to us by an aerospace, a prominent aerospace company. And yeah, CATIA is used widely in the aerospace industry, and we do have a lot of customers currently using it. But you notice when I import this model, and by the way, it's so easy to import things into SpaceClaim. I just drag and drop it right into the gray area, and the model opens up on the fly. You see all the PMI dimensions that were in the CATIA model get transferred to the SpaceClaim document. Now here's what's great about it. All the reference planes, all the reference geometry that CATIA uses to define the PMI data, SpaceClaim recognizes those too. So as I pull on a face, see that dimension just to the right? It's now just about 30 millimeters. It's updating as I make this change on the model. Now wouldn't it be great if you could use that dimension to actually change the location of the face? You can. You click on that little spark, and I could say, let's make that 20 millimeters. And so any dimensions you see on the screen, I can go modify the geometry using those dimensions as driving dimensions, although they're actually annotation dimensions. Even if I have symmetry, or if I want to preserve symmetry about a couple of faces, I can still do that. I could say, let's make that 20. Both of those faces get pulled out, and I've got a symmetric move, so that dimension still is maintained at 20, right around the center. So really any of the dimensions on this model I could go modify, and I could go update the annotation to drive that change. Now this one jumped up there, but you see it's 9 millimeters, and that whole size increased a little bit as well. A common question we get from people often is, can you now take these annotations and put them on a drawing sheet? Yeah, absolutely I can. If I make a drawing, which by the way we give you a front, right, and a top view right away when you open up a drawing. All I have to do is say show the dimensions on any or all those annotation planes that actually have dimensions on them. Some of them don't have dimensions, so I'm just going down the list right now. And actually I need to turn maybe some layers on as well. So I could turn a layer on that shows the annotation planes. And there's a couple more dimensions. So yeah, all those dimensions we can make visible down at the drawing level as well. Alright, so one more example I want to show you, and this is really relevant. And so just to recap this, I mean, this is excellent for not just designers and engineers, but in manufacturing too, for conveying information in that 3D fashion. I mean, as a society, as a business, and as technology is evolving, we're very much moving away from 2D paper prints, although they're still used out there quite a bit. People are moving into conveying information in 3D and manufacturing information in a 3D fashion. So this is very relevant for someone that's a machinist to be able to get this model and see all the necessary data they need and make any modifications they need in order to make the part manufacturable. So one last example I'll give you that's very relevant for analysis. And the example I'm going to give you serves a couple of purposes. There's one thing I'm going to do, but it serves two different markets or interests, I'm going to say. The first is analysis, but the second is IP protection. So you're looking at a cylinder head right now. Oftentimes what an analyst needs to do is extract out a volume from the inside of this and analyze that. That can be very time consuming to do. With SpaceClaim, we've developed this unique tool where this process of extracting out a volume we can get down to just minutes. Now, we've been told from some of our customers that extracting out a volume like this can take hours, days, and actually weeks to do depending on the complexity of the model. And honestly, we really don't care about the complexity of the model because of the power of this tool. It's so simple. All I have to do is select inlets and outlets of the model, and I can already see the preview of the volume that SpaceClaim is going to create. That was just a little diagnostic tool there that helps me make sure that I've captured all the inlets and outlets of the model. And so anytime I see red faces on the protruding into the outside, I know I've got something wrong. But I had red faces only on the inside there, so I'm pretty sure this is going to work okay. And again, we've been told by our customers that what takes them days and weeks to do, we've been able to get down into just a process that takes 2 minutes, plus or minus. So in a couple seconds here, I pretty much have that internal volume created and I'm done. So let's take a look at that in detail. So now the analyst can take this model, this extracted volume, and run through as many iterations as they need to and want to. And if they need to modify this geometry, to run through an iteration again, you remove rounds or get rid of certain faces, they can easily do that in SpaceClaim. If you want to look at just the water jackets, oil jackets, or the cylinder section itself, you can extract out just that volume or start to cut this model up in any which way you need to. Now let me undo for a minute, because this volume extract operation I showed you, the way I showed it, is relevant for the analyst. But we also integrated into this tool the ability to merge the created volume with the original. And this is actually done a little bit quicker. You see, it took about 2 seconds to do. What you're looking at now is essentially pouring concrete into the model and bricking the whole thing so that no one can see details on the inside. So if you are a supplier of CATIA models to someone and you want to hide internal sections, internal features that are proprietary, but you need to show the outside of something, well, this is an excellent tool to just get that job done lightning fast. Literally, it took 2 seconds to create this after I selected the surfaces, the capping faces and edges. And look what you have. In my cross section, I've got a solid body everywhere, so you know that you've hidden everything on the inside, and it's not just a shell of something on the outside. So just to recap the 4 models that I showed you today, I want to stress the importance of how SpaceClaim is extremely easy to use. We've set it up for the person that's not what we might call a CAD jock, dedicated to learning or using CAD software 8, 9, 10 hours a day. An engineer that needs to use 3D and can benefit from the tools in 3D without all that complexity. But also SpaceClaim is extremely interoperable, and that's why we're here today talking about the integration we have with opening up and saving out to CATIA files. So all sorts of things that the manufacturing industry and machinists might need to be able to do, whatever industry you might be in, automotive or aerospace. And if you're an analyst, we've got the tools to help you get those jobs done extremely quickly and easily. So thank you very much for watching, everybody. We hope you have found this informative and interesting, and we hope to see you on future SpaceClaim webinars.